Number 87, find the current through a person and identify the likely effect on her if she touches a 120 volt alternating current source. Letter A, if she is standing on a rubber mat and offers a total resistance of 300 kilo ohms. All right, interesting. So what we have to do is we got to figure out a formula if we know one that relates current, because that's what we're trying to find, voltage and resistance. And doesn't that sound like Ohm's law, right? Sounds a little bit like Ohm's law. So Ohm's law, remember, is current equals voltage over resistance. I like to remember it as VR. V is equal to IR. Doesn't really matter, but it's better to use this form because it's already solved for current. So all we got to simply do is plug in the voltage of 120 volts, divide that by now 300 kilo ohms. Be careful, you don't need kilo ohms, you need ohms, so you got to multiply that by 10 to the third. And all we simply have to now do is multiply. So, we'll divide. 120 divided by 300 times 10 to the third. And we get a value of about 4.0 times 10 to the minus fourth amps, or aka 0.4 milliamps. Ain't really going to do much. All right, should be fine. And the letter B, what happens now if she's on a 400? Has a resistance of only 400 now. I don't know why that only is there, but it's more. So anyway, it's going to be the same calculation. It's going to be 120 divided then by that new value, 4,000. Be careful, you need ohms, not kilo ohms, so multiply that again by 10 to the third. And let's see what we come up with now. So it's going to be 120 divided then by 4,000 times 10 to the third. So now this is 3.0 times 10 to the minus fifth amps. Well, that's 0.03 milliamps now, so it's not even going to be perceived. All right? So as you can see, it's not the voltage that'll kill you. It's the current that'll kill you. So you'll be all right. All right, guys, take it easy. Hope this helped. And don't test this problem out. Take care.